We're stuck in this tree. I think we're falling in this plant. We're in this plant.
Yo, me too.
DJ, drop that beat.
I've been in a plant, I've been wondering now. Why is chlorophyll green? What do they absorb? Who can tell me? I've been in a plant, I've been wondering now. Why are there different pigments in the thylakoid? Why? It absorbs different color scheme, but it reflects off green. Since it doesn't absorb, a reflection pigments perform. Different kind of chlorophyll, we have A and B. What they do? Oh, what do they do?
All this chlorophyll I'm talking about, I don't know what they're doing. They absorb different ways that we are viewing, and different colors are absorbed. I know it. Chlorophyll A absorbs in red. Chlorophyll B absorbs in blue, and assists in capturing light energy. Now it's different structures, and nobody telling me now what's stroma, what's lumen, what's a thylakoid. They say everyone knows about lemon and grana, but I don't even know.
Grana is stacks of thylakoids, which are pockets or sacs. Yeah, these are thylakoids. What else are thylakoids? Sacs that contain pigments with different chlorophyll and carotenoids. It's the main part, has a big role. Lamella holds thylakoid. Lumen is a liquid inside. In the thylakoid. What about stroma? A fluid that's colorless in the chloroplast that surrounds the grana. I feel like I understand.
Now I wanna know. Chemical formula for photosynthesis. Yeah, I wanna know. You need 6 CO2, you need 6 H2O, and some light energy inside the go. Now I wanna know. What happens after photosynthesis? Yeah, I wanna know. You have glucose, C6H12O6, and some oxygen. 6O2. Dependent reactions talking about who you think you know it. The purpose for energy captured from the sun in chemical form, and it's in the thylakoid membrane. I know it. The big players are photosystems and electron acceptor proteins. Photosystem 1 and 2. And PS1 makes NADPH. Ain't nobody asking about PS2. Where you been? Where you at? What's your mind? But it helps make the ATP captures light using proteins, lipids, and pigments. Electron acceptor proteins, yeah. Move electrons from PS2 to PS1 through redox reactions. Yeah, whoa, ooh, yeah.
It's the very first step with light absorbed pigments excites electrons. Electrons then move to first protein in ETC. PS2 is oxidized and membrane protein is reduced. Electron move along ETC, releasing energy bits along the way, powering proteins, pumping H plus from stroma to lumen. Lights absorb PS1, excites electrons. Electrons along ETC where it belongs to NADP plus to H plus to from NADPH. I know where you are, where you're going. I know you know the Calvin cycle. What's the purpose in this cycle? Inorganic to organic, where it take place. In the stroma it does, but you gotta know right now. You got 3 stages to give right now. I've been in a plant, I've been wondering now. 3 steps of the Calvin, it starts with fixation. Who can tell me? Fixes inorganic to organic carbon. Then reduction weight transfers electrons from acceptors to carbon. Now we have regeneration, which returns the original molecules used in step 1.
Different enzymes want to be alive. Phase 1 is RUPB and CO2. Phase 2 is phosphoglycerate, ATP, and NADPH. 5 GRP2 regeneration. 1 yield to glucose and fructose. Phase 3 for G3P and ATP. Finally know now why it's called cycle. The whole process repeats through regeneration, and then fixation starts again. That's why it's a cycle. Why it's a cycle? Well, that's a cycle. Chemiosmosis. I know. Generates ATP with H plus. Yeah, but it has 2 different stages. First, photolysis of H2O, but I want to know number 2. Pumping H plus into the lumen along the electron transport chain. Now I want to know. Carbon fixation pathways. 2 different ones, C4 and CAN.
C4 fixes CO2 into 4 carbon compounds. then stored and fixed in mesh sporal cells,
then released into bundled sheet cells. CEN is a type of C4.
opens stroma at night and closes at day, the opposite of C3.
That's all we need to know.
That's all we need to know.